All right, here we go. So tree diagrams 9E. So I think we're sort of up to 9D.2/9E. We're just continuing with probability calculations. And maybe this is a skill we've seen before, maybe not. But I reckon we'll pick it up pretty okay. We should be able to dedicate some time to the folio task today as well. So we've got tree diagrams and we're just going to leap straight into the example. We've got a bag of goodies. This is a bag of goodies. It's got 5 Mars bars and 3 protein bars. Mr. Muscle picks 3 bars at random without replacement. So he's picking out bars and he's not putting them back, which means the probability is changing each time, right? Whenever we don't have replacement, the probability is going to change. Draw a tree diagram to illustrate all of these outcomes. So what's going on, he's going to make a pick, all right? And for the first pick, he could either get a Mars bar or a protein bar. So we'll denote them with M and P. All right, and the probability of getting a Mars bar, well, if he gets a Mars bar, there are 5 Mars bars out of 8 bars in total. So it's more likely that he's going to get a Mars bar. And for a protein bar, well, there's 3 protein bars out of 8 possible bars in total. Notice here at the first step of our tree diagram how the probabilities add up to 5 on 8 plus 3 on 8, 1. The 2 possible events, all possible events add up to 1. He's either going to get a Mars bar or a protein bar. There's nothing else that can occur in the bag of goodies. Okay, so let's pursue this branch of the tree, and I'm just going to keep pursuing the topmost branch. If he gets a Mars bar, okay, he's pulled 1 Mars bar out. What that means is there's now 4 Mars bars out of 7 Mars bars in the bag, okay? So he's pulled 1 Mars bar out and he's going to repeat the experiment again. So the probability of getting a Mars bar again, because we've pulled 1 out, there is 4 left out of 7. Okay, and there is still 3 protein bars, but out of 7. Okay, and again, pursuing the topmost branch of the tree diagram, if he's pulled out 2 Mars bars, that means there are 3 Mars bars left out of 6. And 3 protein bars. Alright, so you can see we've got the first branch of the tree, here's the second branch, and this would be the third branch. So I'm going to fill out the rest of the possible combinations. Maybe he's got a Mars bar and then a protein bar. If that was the case, he could get a Mars bar, a protein bar, and then another Mars bar, or another protein bar, okay? So if he got 1 Mars bar and then 1 protein bar, there are 4 Mars bars left and 2 protein bars left. All right, 4 out of 6 and 2 out of 6. Okay. So let's see here what's going on. We can see the possible combinations. You can get 3 Mars bars, 2 Mars bars and a protein bar, a Mars bar, a protein bar and a Mars bar, okay? So we're just filling it in accordingly. Let's say you got a protein bar first, then the probability of getting a Mars bar is going to be 5 out of 7 and 2 out of 7 for another protein bar. And again, Mars bar, protein bar, Mars bar, protein bar. So that's going to be 4 out of 6, and that will be 2 out of 6. This will be 5 out of 6, this will be 1 out of 6. Okay, so that is our tree diagram. Okay, next we're going to perform the probability calculation. So if you do have questions about how we develop that, please let me know when I'm coming around. But what we can see is the first bar that he pulls out, the second bar, and then the third bar. All right, all the possible combinations there that can occur. So the first question we are asked is, what's the probability of getting 3 protein bars? All right, 3 protein bars. If we're going to get 3 protein bars, that means the event P has occurred. We're pursuing 3 protein bars back to back, no Mars bars. So he's pulled one bar out, it was a protein bar, reaches in, grabs the next bar out, protein bar. We're pursuing this branch of our tree diagram. This is the only way that it can possibly happen. And so the event PPP is 3 on 8 times 2 on 8, 2 on 7. Okay, it's complementary events, right? And 1 on 6. 3 times 2 times 1, and 8 times 7 times 6. So you can multiply at the top, 3 times 2 times 1, we'll have 6 at the top, and at the bottom, 56 times 6, we'll have 336. And in simplest terms, one on 56, or as a decimal, 0.01785, 0.01799. Now remember, I've said we prefer to keep it as a fraction because it includes every decimal place, right? That being said, you won't be penalised if you do write it as a decimal. And the other thing to say about this is, remember, probability occurs between 0 and 1, right? So basically that's like a 1% chance, almost a 2% chance of getting 3 protein bars. Pretty unlikely that performing the experiment you're going to get 3 protein bars in a row. Okay, what about the probability of getting no protein bars? Okay, so if you're getting no protein bars, let's see. It's definitely not this branch, okay? It's definitely not even this branch because you're still getting 2 protein bars there, 1 protein bar there, 2 protein bars there, 1 protein bar there, 1. It has to be, the only way that can possibly occur is if we get all Mars bars. The only way you can get no protein bars is if you get all Mars bars. So what we're doing then is we're calculating what's the probability of getting all Mars bars. So this time we're following the top branch, aren't we? We've got 5 on 8 times 4 on 7 times 3 on 6. Now at the top we've got 5 times 4 times 3. So what's that? 12 times 5, we've got 60 on 336. So that's going to be 10 on 56, 5 on 28. Alright, just as simplest fraction, I think that's right. 60. Yep. Okay, very good. Next one, at least 1 Mars bar. Okay, at least 1 Mars bar. What this means is you could get 1 Mars bar, you could get 2 Mars bars, or you could get 3 Mars bars. So this event, right, the way this could happen is let's talk about all the possible events that satisfy this statement. You could get 3 Mars bars, you could get 2 Mars bars and a protein bar, you could get, all of that has at least 1 Mars bar, okay? Here, you've got at least 1 Mars bar, here you've got at least 1 Mars bar, here you've got at least 1 Mars bar. There's only one path where you don't get at least 1 Mars bar, and that's the circumstance where you get 3 protein bars in a way. So they're saying at least 1 Mars bar. Now there are 2 ways you could calculate this. The long way would be to calculate, okay, all Mars bars plus 2 Mars bars and a protein bar, plus a Mars bar, a protein bar, and a Mars bar, plus, and you can see it just gets ridiculously long, right? Or you can recognize all probable events add to 1. And the only event that's not included is the probability of getting 3 protein bars. That's the only one that's not included. Which means if we do the number 1, the probability of all events, take away the probability of getting 3 protein bars. We have all probable outcomes. Take away this one, we're left with all the rest added together. We don't need to add them up individually. Okay? So we're doing all of these events add up to 1. We're going to take away this possible path, and it's going to leave the probability of all the other paths added together. And we've already calculated that here. We saw it was 6 on 336, right? So we have 1 take away 6 on 336. So that's going to be 330 on 336. Yeah? What's it simplified to?
55 and 56.
Thank you. Alright, so it's very likely that you'll get at least 1 Mars bar. Okay, you can see it's all like 97%. Okay, and then the next one says, how about the probability of getting exactly 2 Mars bars? So there's a number of ways this can happen. If you're getting exactly 2 Mars bars, then the fastest way to do this one is just going to be to circle the paths and calculate them. So if we're getting 2 Mars bars, that means we could get Mars bar, protein bar. We could get a Mars bar, a protein bar, and then a Mars bar. Okay, so let's see. Mars bar, protein bar. Mars bar, protein bar, Mars bar. Okay, that's 2 Mars bars. And then the other way, protein bar, Mars bar, Mars bar. All right, there are 3 possible ways that it can occur. And so we need to calculate each event and add them together. We can't perform a subtraction here because there's too many possible paths. All right, so Mars bar followed by Mars bar followed by protein bar. I've got 5 on 8 times 4 on 7 times 3 on 6. All right, so that's going to give me my 20 on 336. And what you'll find is actually each of these events is the same. All right, because all you're doing is ordering the numerator differently. The denominator stays the same. The numerator is ordered differently, and order of multiplication doesn't matter. And so all of these events add up to 60 on 336, which we evaluated before, 5 on 28. Okay, so the probability of getting exactly 2 Mars bars. Hang on, that's 60, isn't it? 5 times 4 times 3, that's 60, that's 60, that's 60. This is 180, sorry. And we add them all up, 60 plus 60 plus 60, 180 on 336. And what'd you say, 15 on 28? Yep. All right, does everyone feel okay about drawing the tree diagram and calculating those probabilities? Yeah. Any questions? All right, very good. So let's continue then. So if we have a look at our checklist, we just did a set for homework sort of 9D1, 9D2. So we should be up to 9E. Let's see how we go with that exercise.